suggestion. So I'm recording this for the sake of those who are not present because you're not even 10 inside the classroom now. So how do we determine the composition of the overflow and the underflow analytically in this case? Anyway, this is the last topic in midterm, and this is a short topic actually. If you're going to dwell on the analytical approach, then there will be new learnings if we will not limit ourselves on the two books that we have. That's John Cookle's and McKeep, because more on graphical approach is being used there. So I'll go back to my question. Last meeting, I ended with the question, how do we find the composition, knowing that so far in in this particular separation process, all we have as a tool is material balance. So going to that, how do we determine the composition of the overflow and the underflow in this case? Okay, I would just like to go to my board. I'll stop sharing for now. While you are thinking, how do we determine the composition? Anyone? How do we determine the composition? Oh, sorry. Let me know if you're seeing my board already. Are you seeing my board?
No, Miss.
No, okay. Sorry. Share. Share. I think you can see now the board. So I'll go back to that. So because we need to finish this one, we go before we go to a new topic, and I want you to see. So how do we find the composition of the overflow and the underflow in this case? On, the only tool so far that you have learned is material balance. So how do we do that? Anybody? Is that person not around? There was a suggestion last meeting on how we go about finding the composition of the overflow and the underflow. What do we do? We use what? Anyone? Nothing in mind? What would you do if you're the one use? What I'm trying to say now is that you have nothing, no formula, no empirical formulas to use, no graphs, no tables, just a simple case of material balance that in itself will tell you what you will do. So what will you do so that you'll know the composition?
Matry lang ko, Miss.
Oh, Kat, give me a suggestion. I'll be the one to write down what you're suggesting. What will you do?
Ma-solid balance, Miss.
Oh, it's okay. Correct. So you will do solid balance. You're correct. If you're going to do solid balance, then isn't that something that will lead to determining the inert solid only, or the streams that has the inert solid if you do the solid balance? What solid are you referring to in here, Kat? The inert solid? Let's be
Ang,
very careful with leaching, because when we speak of solid, we have two solids here. The inert solid B and the solute A. That's also a solid that has been leached out or taken out by your solvent C. So what solid balance are you referring to when you say you will do solid balance?
ang solid, Miss, sa L. Sakto.
Kat, what
Ang
solid?
solid, Miss, sa LO, Miss.
Ang solid sa LO. So I will make you choose. What solid is that? The A solid or the B solid? We have two solids, right? Our
Ang A,
matrix,
Miss.
ang A. Are you sure it's the A? With leaching, we have to be very careful on the solid that we're referring to because we have two solids, the inert solid B and the solid A, which we will take out in the matrix with B. Kwaon mo siya sa matrix ni B. Okay, solid ni mo, solid liquid extraction ni kwaon mo si A, separahon mo sila ni B. So in this case, we are going to do, I'll write it down, we are going to do A balance. I will not write solid balance because you might get confused because there's already a solid balance that we used last meeting. And that solid balance led us to determining the amounts. If you can recall and if you have reviewed the recorded video, doing the solid balance led us to determining the underflow and the overflow. Without doing that, we cannot find the overflow and the underflow unless otherwise you do graphical. And we want to do away with graphical. So now I'm saying we do A balance. So if I do A balance, can somebody dictate to me what would be the equation for A balance? What would be our equation for leaching in A balance? Anyone? Fifth year, you have to let me know that you are ready to graduate. And one way that you're telling me that you're ready to graduate is you're thinking. It's not that you're just waiting for me to give everything to you. Otherwise, then I will not be that convinced that you're ready to graduate. So give me a balance using a balance equation, a material balance equation based on component A. I have given you already the material balance equation last meeting. So how would I write it now? Oh, I have given already the material balance equation. How would you write your material balance equation specifically based on solute A in leaching, single stage leaching? Mhm. I have here, let's see. Can you dictate to me the material balance based on solute A? Jenny Fernandez, what would be our material balance based on solute A? Where is Jenny? Jenny,
Ah, yes, Miss.
how would we write the solute balance in this case? Leaching. Can you dictate to me the equation?
Um, Based on A, Miss.
Yes, based on A.
Is it N uh the NOLO, Miss, last time?
A balance. The N is
Okay.
for B balance. This is
Okay.
A balance that we're going to do. How would we do that?
So the LO plus V, Miss, or
We're, we're balancing the A in our leaching process. So if you're telling me that would be LO plus something, that's missing something. Okay, you need some help. We'll ask somebody. Ino, can you please give me a suggestion? Or yes, Ino is here. Ino, can you
Yes,
give me,
miss.
yes, can you dictate to me the A balance for leaching? For example, problem number 2. Okay, Ino will be needing help from John Home. Home, John. Would you know
Yes, miss.
how do we write the balance on A? Hmm? I've discussed this. I won't ask this if I haven't discussed it in the first place. I discussed it last week. And after discussion, I right away uploaded the recording. So you have ample time to review what was discussed. So another one who would
Ex
know that
eh, excuse me, ang question is ang ginanamin mga balance is component balance on A.
yes, the A balance.
Ang amon siya miss ang LO YAO plus V2 XA2 equals M XAM.
MXAM. Okay, BG. That's correct. Very good. So notice class that BG used Y instead of X for the L and X instead of Y for the V. And now there is this occurrence of the MXAM. Now, if you're going to use this BG, correct, this is correct, you have how many unknowns in this case? How many unknowns do you have in this case?
First ang XAM
Okay, I'll have this as equation 1. Okay, you need the XAM. Do you know already the M?
ang M blamis dos ang last is 120
So M, but to review, how do we determine the M?
ng
Your M is LO plus V
LO plus V2
is equal
equals
to M,
V1 yes,
which is equal also to V1 plus
plus
L1.
L1.
You're right. Our answer last for V1 and L1 should give us the M. In the same way that if we use the given for LO and V2, we'll also be getting the M. So either which you go about finding the M, either using these two or these two which we last determined, you will still find the M. So let's see. Your LO then, in the problem, I'd like to read the problem so everybody gets to be reviewed on it. The problem says that you are given a 100 kilogram of soybeans containing 20 weight percent oil, and your solvent is 100% organic in the form of hexane. That's so far the information that we used. So I feed that is 100 kilogram soybeans containing 20 weight percent oil and a 100% organic solvent in the form of hexane. So that's our problem. So I'd like to go back to the M that we are determining a while ago. Where is that? Sorry. So I'll go to my board. Now, so what is our M? So you have a 100 kilogram soybeans containing 20 weight percent A. So my LO would be what?
20.
20. Do si Big G lang ako ni estudyante. Remember, class, again, review because leaching is very different than the other separation process. When you do material balance on leaching, you are only accounting for the solute A and the solvent C. You're not accounting in the overall material balance the inert solid B. So that is why BG was correct when he said that your LO representing the feed should only be 20, which is simply the A in the feed. You're not supposed to add the solid, which is 80, which is now a total of 100. So in this case, that would be 200. Now your solvent, if you can recall what I have read a while ago, is 100% solvent in the form of hexane, and it is 100 kilograms. So you see this 220 plus 100 will give you an M, which is 120. Now, in our last meeting, you were given the values of these two. And the value of those two, I forgot, is, do you have it there, BG?
Ano
B1?
nga ba? V1.
B1.
V1 is... Talagang siya, miss. Well,
Yes,
66.7, Miss.
56 point.
666, Miss.
Okay.
0.7.
So this is 66. Sorry. This is 66.7. And an L1, which is 53.
Yes, Miss.
53.33.
Why am I knowing that it's 53.3? Because this 2 has to be 120 also. Because either we should do it, you do material balance, overall material balance, using the original streams, or you use the values that we got from our previous calculation, that should give you 120. So BJ is correct. Your M is 120. Now, based on the equation that BG gave a while ago, he said that we still need to determine the XAM. And he is right. We still need to determine the XAM. How do we determine the XAM? You use the value that you used here together with the correct concentrations. Again, don't forget that your concentrations here in terms of A will not be divided by the sum of the masses of A, B, and C. That would only be over A and C. So in here, if I'll substitute now the values on equation 1, my LO is 20. Now, your YAO, this is the concentration of A in the feed, that would be 20 over 20 plus 0. Now, I'm writing it specifically here so you would understand that your feed does not contain any C. It contains only A. So as such, in terms of concentration, your feed has a concentration of 1.0 because it's 20 over 20. I'm writing it specifically here so you would understand. Now, in terms of what you have for the V2, so your V2 is 100. We know that it's 100 because it's pure hexane. But notice that it is to be multiplied again by the concentration of A in the solvent. And since this is 100% C, hexane, then the concentration for A will be a 0. Because we don't have A, or we don't have the oil present in our solvent C, which is hexane. So this is 0. Now I will have the M, which is, we know, 120, and I have XA. Now, the purpose of finding the XAM is so that later on, when you do your solid balance based on A, based on this A here, you already have the XAM. Because if you don't have the XAM, then you cannot still solve the other YA1 and XA1 values. In this case, you will have an XAM equal to, so 120 divided by 20. Or 20 divided by 120, sorry. The other way around.
0.167, Miss.
So
0.167.
0.167. Now, since you have this, you're ready to set up a new A balance. This A balance that you have is based on the entering streams. Now, we want to make another A balance based on the streams that have been equilibrated. Those are the streams we call the overflow and the underflow. Our goal is we will determine the composition of these two. Okay, so I'll go to the next sheet here. So we will set up another A balance. Can somebody dictate to me what would be the A balance in this case? Okay, what would be our A balance in this case?
Ang values na, miss.
No, you have to set up a new A balance based on the equilibrated streams overflow, and underflow. So set up first the equation. What would be our equation? The other equation for A balance, wherein you have the streams overflow and underflow. That would be, because in here, class, your A balance here is based on the feed and the solvent. LO is your feed and V2 is your solvent. Now, what I'm asking is another A balance, but this time it should be based on your overflow and your underflow. How would we set it up? It's just the same in terms of pattern with the feed and the solvent. How do we set it up? That would be, so you write of course ln, that would be multiplied to yan plus v1 xa1, right, equal to the mxam. And this is the other side of the equation. The other side here, if we have written another equal sign here, that would be the other side. Now, these are the equilibrated streams L1 and B1. We want to determine YA1 and XA1. Okay, so I will have here L1, which is, in your case, that is 53.3. So we'll place here 53.3. I have YA1 plus you have B1, which is 66.67, XA1, and this is equal to 120 times 0.167, the one that we got here. Okay? Now, if you look at the equation intently, and I don't want us to do graphical, it has two unknowns. So this is your equation 2. What would you do next since we have two unknowns, only one equation? Natural thing to do will be you have to look for another equation that you will use simultaneously with this, or an equation relating xa1 to ya1 or vice versa, which you can substitute here. That way we'll find xa1 and ya1. Do you have such an equation? Or would it be possible, or is it possible rather, to set up another equation relating ya1 to xa1 or vice versa? Would it be possible? So, ang question lang man is, posible pa nga makaobra pa ta isa ka equation. So far sa na-discuss sa inyo, may isa pa ka equation nga ma-set up or wala na, miss? Wala na, hindi na kami ka-set up equation kaya amo naman na siya tanan. What do you think? You can utilize in leaching 3 equations: the overall material balance, the solute balance, and the inert solid balance. Have you utilized all 3 already? Nagamit na sila nga tatlo?
Wala pa, miss, ang inert, miss.
Wala pa. Nalipat ka na, Kat. Nagamit na siya, Kat. Sanglas.
Ay, sad, miss.
Nag-B-balance kita para makuha ta in the first place si L1. Kaya kung hindi ta nag-B-balance, hindi ta kasolve kay L1. Kung hindi masolve si L1, wala ta V1. So we have used already the B-balance or the inert solid balance. So ang pamangkot ko naman lang, yes or no naman lang ang sabat. May magamit pa ta nga equation? Ang tatlo nagamit na naka-overall material balance na kamo. You have done also solute balance, that's A balance, and you have also done inert solid balance. By the way, class, I'd like to emphasize this. The inert solid balance is normally used when you want to know the composition of either the feed or of the underflow. That's the only purpose that it's being used. Otherwise, it's not being used in determining compositions of the other streams. Okay, so we have used it already. So I would like to answer na lang my question. So the answer is no. I can't have, and it's not possible anymore to set up another equation because we have used all three. Then, based on what I have discussed on the fundamental principle of leaching, what is it that you can recall that we can use here? That way I can find XA1 and YA1. Somewhere in my discussion last week, or Tuesday last week, I have discussed how is shall I say, the composition of the slurry in the underflow associated with the composition of the solution in the overflow. In both conditions, constant underflow or variable underflow. Can you recall what was that part of the discussion? We have two scenarios in leaching, the one that is constant underflow and the one that is variable underflow. So review tabi. Ano ang recollection nyo? Anong ma-recall nyo sa constant underflow kag sa variable underflow? What have we discussed about those two? Because if you can't recall those discussions, you cannot answer this. And you will really go to graphical approach, and that would be bad because you can do this analytical. Although I'm not saying it's not correct, but we want to do away with graphical approach. So what do you recall? So I'd like to go back. What do you recall about variable underflow and constant underflow in our discussion? What can you recall? Wala, gid may nadumduman.
Ang amount retained, miss, is a function of concentration.
Oh, generally correct in a cat. The amount retained by the what, cat?
Of the solution is a function
Of the what?
of the solution.
Of the solution. The amount of solution retained by the what?
The amount retained, gali, miss. Amount retained.
The amount of solution retained by the what?
By the solution,
By the solids in the slurry is dependent on concentration. Amo na siya ka, di ba?
miss.
For everybody, the amount of solution retained by the solid in the slurry is dependent on the concentration of that particular solution. If I will translate it in our dialect with English, ang kadamuon bala sang solution nga nagaupod sa solid sa underflow, nagadepend na siya sa concentration mismo sang sina nga solution. But we have two scenarios. The two scenarios is that we have what we call a constant underflow and a variable underflow. It's connected to this particular fundamental principle or concept that Kat has mentioned. What is that? Or shall I say, you just give the constant underflow because the other one will be the opposite of the constant underflow. What is that? Ano ni siya ang constant underflow nga scenario? Wala na gid may ma-recall. Sige, hindi na lang naton pag-recall. O, hindi tabi pag-recall ang constant underflow kag variable underflow. Miski hindi nyo pa na siya ma-recall, there is this fundamental principle connecting the solution in the overflow and the solution in the underflow. What is that very important principle? Whether you have a scenario of constant underflow or variable underflow. What is that?
Matry ko, miss.
Sige ka.
Nang equilibrium, miss. Hindi.
Ang equilibrated is ang streams na gahalin sa particular nga leaching apparatus. So if we say, if we have a single leaching stage, the streams that are living there are said to be equilibrated. Wala na siya sang may ginlain sa iban nga separation processes. Whether single stage or multi-stage, the living streams or the streams that leave a particular equipment are said to be equilibrated. Correct na siya. Pero hindi na siya mga kumangkot. Ano atong fundamental nga principle sa leaching? Nga kinahanglan madumduman nyo gid kay kung hindi nyo ni siya masolve. Hindi nyo siya masolve, pwede nyo siya mapangitang answer sa graphical, pero hindi siya masolve. Ano to siya? Or if you have your notes there, you can read it there because ara da ang ginapangayo ko. Ano na siya? If you will be disconnected, click lang liwat ang link ha, kay less than 1 minute na lang ko. What was that?